Session 8, Height Measurement. In this session, we divide it into three parts. First, definition, and then use of tool procedure, then processing and presenting the results. Definition. A surveying instrument known as an optical level is used to project a horizontal line in two directions, forwards and backwards, so the difference in height can be measured. At each end of the line being measured, the value is noted where this horizontal line intersects a vertical step, or we can say it leveling step. The difference between the values at each end of the line gives the difference in height. Provided the line of sight is kept relatively short, usually less than 50 meters. By repeating this process in a leapfrog manner and adding up all the difference in height, the total difference in height between two very distant points can be calculated. If the first point is a tight gauge where mean sea level has been measured, all the points will have non-height above mean sea level. But if there is no mean sea level, we can use certain height as reference. Here's the picture of the step. We can see the picture as first setup, second and third, and go on. And here's the tools. Of course, we'll use outer level and tripod, stationary and foam sheet, measuring tape, and leveling staff. Here we discuss about the use of tool procedure. There are three steps. First, determining the lengthwise points and the transverse points. Then, centering and balancing the outer level. And the last, capture the data. First, determining the lengthwise points and the transverse points. Use stable and durable mark that are appropriate to the station of the area of interest. Make sure there is no obstacle between the marks. Make sure the mark is easily recognized and not disturbing other works. And make sure that the angle between lengthwise points is 180 degrees and the angle between lengthwise point and transfer points is 90 degrees. And here's the second step, centering and balancing the outer level. First, pair the outer level to the tripod, and then place the tripod and outer level right on the top of the mark by using a pendulum. Then balance the outer level by looking at niveau and we set it until the bubble inside get to the middle. And to capture data, aim the sign inside the binoculars to the next lengthwise point or transverse point. Don't forget to set the lens focus until the leveling staff looks clear. After the leveling staff looks clear enough, do a small rotation with the screw like the picture below until the sign is right on the leveling staff where there are some value of height. So, record the height of data, upper sheet, middle sheet, and bottom sheet on the leveling staff. Measure the height of outer level with measuring tape. Measure the distance from outer level to the target point with measuring tape. And repeat steps above to the next lengthwise point. And here's table of foam sheet. In this table, we'll write on the data. As we can see, here is the start point, destination point, distance, and the tools height, upper thread, middle thread, and bottom thread. And this table 2, middle thread of lengthwise profile. Here, I've already wrote the equation, how to calculate it, and how to use it. It's very easy. And then here's the middle thread of transfer profile. Just like before, we have start point, destination point, and we have upper thread and bottom thread reading, middle thread reading, and middle thread by calculation, and middle thread average from reading and calculation. And here's the lengthwise profile elevation, and I've give you some little example. Here we have start point and destination point, A to B and B to A, B to C and C to B, and go on. And we have middle thread to height, distance, height difference, height of thread, and by doing this table, we'll find the elevation of the lengthwise point. And here is the example of the picture. As we can see, here is the lengthwise point. Of course, it's elevation. And the next is for transverse profile elevation. Just like before, we have start and destination point, middle thread, and here we can find the elevation of transfer point, just for example, point A1, A2, A3, A4, and other S. And here's the example of transfer point with its elevation. I think that's all for session 8. You can try it by yourself using the auto level. Thank you.